Dear students, welcome to the lecture video on Newton-Raphson method. In this video, we'll see the solution of the algebraic and transcendental equations by using the Newton-Raphson method. We all know that fundamental property of all real valued function. If a function has opposite signs for two values of x, say at x is equal to a and at x is equal to b, f of a and into f of b is less than 0, definitely the equation f of x equal to 0 has at least one real root within the interval a comma b. That is a fundamental property of all real valued functions. And in this topic, we are discussing two methods. One is the Newton-Raphson method and another is the regular-Falsy method. Newton-Raphson method is an iterative process. Okay. In this method, we are locating an approximate real root of the given equation and improve its accuracy by an iterative process. Hence, this is the iterative method. Suppose if f of x equal to 0 be the given equation and x naught be an approximate root of the equation, if how to locate the approximate root means by error and trial method by using the fundamental property. Suppose if the root lies within the interval a comma b, means f of a into f of b is less than 0, definitely there exists a root within the interval a comma b. And suppose if modulus of f of a is nearer to 0 rather to modulus of f of b, then we are taking a is the initial approximation to the root. We are calling it as x naught. X naught be an approximate root of the equation and h is a small correction applied to it. Then x naught plus h is the exact root and we try to find h such that f of x naught plus h is equal to 0. How to find this h? There are many methods. Here we are using the Taylor series method. Using Taylor series expansion of f of x naught plus h, we have f of x naught plus h into f dash of x naught plus h square by 2 factorial into f double dash of x naught plus dot dot dot. That is equal to 0 because f of x naught plus h is equal to 0. Since h is a small quantity, h square, h cube, h to the power of 4, etc. Being still smaller, we can neglect those values. After neglecting all those values, the above equation takes the form f of x naught plus h into f dash of x naught equal to 0, or else h is equal to minus f of x naught divided by f dash of x naught. This is the h value. Hence, the first approximation to the root is given by x1. First approximation to the root are denoted as x1, that is equal to x naught plus h. If I substitute h value, then x1 takes the form x1 is equal to x naught minus f of x naught divided by f dash of x naught, provided f dash of x naught is not equal to 0. The second approximation to the root is obtained just by replacing x naught by x1 in the RHS of the above expression. So, second approximation to the root, if we denote it as x2, then x2 is equal to x1 minus f of x1 divided by f dash of x1 and so on. Again, still we can improve this solution just by replacing x1 by x2 in this expression. In general, we can write xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is the Newton-Raphson iterative formula. Now, I'll explain you few problems on Newton-Raphson method. Use Newton-Raphson method to find a real root of the equation x cube minus 2x minus 5 equal to 0 corrected to 3 decimal places. Here the given equation is x cube minus 2x minus 5. So that the corresponding function is f of x is equal to x cube minus 2x minus 5. I'll differentiate that with respect to x. F dash x is equal to x cube differentiation is 3x square minus 2x differentiation is minus 2 minus 5 differentiation is 0. Have not written that. F dash of x is equal to 3x square minus 2. Now we need to identify the initial approximation to the root. For that, error and trial method it is f of 0. Okay, f of x is equal to x cube minus 2x minus 5. F of 0 is equal to, if I substitute x equal to 0 here, it comes out as minus 5. F of 0 is equal to minus 5, it is less than 0. Now f of 1, okay, 1 cube minus 2 into 1 minus 5, nothing but minus 6. It is also less than 0. Now I am substituting x is equal to 2. F of 2 is equal to 2 power 3, 8 minus 2 into 2, 4 minus 5. 8 minus 4 minus 5 is equal to minus 1. It is also less than 0. Now I am substituting x is equal to 3. 3 power 3 minus 2 into 3 minus 5. Okay. 3 power 3 is 27 minus 2 into 3 is 6 minus 5. 27 minus 6 minus 5 is equal to 16. It is greater than 0. Look at this. F of 2 less than 0, f of 3 greater than 0. Definitely there exists a root within the interval 2, 3. There exists at least one real root within the interval 2, 3. Among 2 and 3, okay, the root is either nearer to 2 or it is nearer to 3. Okay, how to select, that is the initial approximation to the root means, look at this f of 2 and f of 3 values. Modulus of f of 2 is equal to 1, modulus of f of 3 is equal to 16. Among 1 and 16, which value is nearer to 0 means 1 is nearer to 0. Okay, f of 2 is nearer to 0 compared to modulus of f of 3. Hence, we'll choose initial approximation to the root as 2. Okay. Modulus of f of 2 is nearer to 0 compared to modulus of f of 3. Hence, choose initial approximation to the root as 2. X naught is equal to 2. Now, first approximation to the root, x1 is equal to x naught minus f of x naught divided by f dash of x naught. Okay. Substitute the values. X naught is 2 minus f of x naught is 2, f of 2 divided by f dash of 2. Okay. How to simplify this means 2 minus, open 2 brackets, okay, f of 2. Substitute x is equal to 2 in the equation x cube minus 2x minus 5. Open 2 brackets, okay, within one bracket, 2 cube minus 2 into 2 minus 5, close the bracket, divided by f dash of 2 means 3 into 2 square minus 2, close both the brackets, equals. If you press in your calculator, then you are getting x1 is equal to 2.1. Keep that answer as it is. Okay. Now, that is our answer is 2.1. Second approximation to the root, x2 is equal to x1 minus f of x1 divided by f dash of x1. Okay. x1 is 2.1. That will be stored in your answer queue in your calculator. Okay. Now, you press answer minus, open 2 brackets. Okay. Answer cube. F of 2.1 means 2.1 is stored in answer key. Okay. Answer power 3 minus 2 into answer minus 5. That is f of 2.1 it is. Look at the equation and press wherever x you required, there you are pressing the answer key. Okay. Close the bracket, divided by f dash of 2 means 3 into answer square minus 2, close both the brackets. Now, if I press equals key, it comes out as 2.09456812. Okay. Again, that x2 value is stored in your answer key in your calculator. Third approximation to the root, x3 is equal to x2 minus f of x2 divided by f dash of x2. Okay. x2 is stored in answer key. So, now you are pressing answer minus 2 brackets you are opening. Okay. F of 2.095 means you are look at the f of x. Okay. X cube minus 2x minus 5 is there. Answer cube minus 2 into answer minus 5, close one bracket, divided by, now f dash of x2 you need to calculate. Okay. x2 is stored in your answer key in your calculator. 3 into answer square minus 2, close both the brackets, equals press, okay, it comes out as 2.094551595. Okay, all the 9 decimal places we have written. Okay, but in the question what they asked is correct to 3 decimal places. Now we'll approximate the solution correct to 3 decimal places. Okay, correct to 3 decimal places means 2.094568181 is there. Look at the fourth decimal place. If that value is greater than or equals to 5, add 1 to previous digit. So 4 becomes 5. 4 plus 1 is 5. The x2 value corrected to 3 decimal places is 2.095. Okay. Now look at the x3. In the x3 solution also, look at the fourth decimal place. It is 5. Okay. Greater than or equal to 5. That value is, add 1 to previous digit. Okay. 4 plus 1 is 5. x3 is also 2.095. Okay. x2 and x3 are identical, correct to 3 decimal places. At this stage, you are stopping the process. Okay. If they ask you correct to 4 decimal places means you are considering the solution correct to 4 decimal places. You are approximating. Okay. Correct to 4 decimal places. So, the required solution correct to 3 decimal places is 2.095. I hope you understand it. One more problem. Okay. Use Newton-Raphson method to derive an iterative formula to find square root of n and hence find square root of 12 they asked. Okay. Here we need to derive an iterative formula to find square root of n and hence after that we need to find, okay, square root of 12 value. We'll take x is equal to square root of n. If I square on both sides, x square minus n equal to 0. X square is equal to n or x square minus n is equal to 0. We'll take that function as f of x is equal to x square minus n. If I differentiate this, f dash x is equal to 2x. Now, Newton-Raphson iterative formula is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, xn minus f of x is x square minus n, f of xn is xn square minus n it is. I substituted. F dash of xn is 2xn, f dash x is 2x, f dash xn is equal to 2xn. Okay, substitute the values. Xn minus f of xn divided by f dash of xn. We'll take the LCM. 2xn is the LCM. 2xn square minus xn square minus into minus plus n. 2xn square minus xn square is xn square plus n divided by 2xn. Okay, or else 1 by 2 into 2. Xn square divided by xn is xn plus n divided by xn, or xn plus 1 is equal to half into xn plus n into n divided by xn is the required iterative formula to compute square root of n. From this formula, we need to find square root of 12. Okay. This is the formula to find square root of n. So, n value is equal to 12. To find initial approximation, look at this. Look at the perfect square numbers. Square root of 9 is 3. Square root of 16 is 4. 12 is in between 9 and 16. Okay. 12 is in between 9 and 16. 9 and 16 are the perfect square numbers. Okay. And 12 is approximately nearer to 9. 12 is nearer to 9 compared to 16. Hence, square root of 12 to square root of 9, that's square root of 9 value is equal to 3. Hence, we can choose x naught is equal to 3. This is one way. Or else, you can also choose x naught in another way it is. Because f of x is equal to x square minus n values 12 it is. Okay, by error and trial method. F of 0 minus 12 less than 0. F of 1, 1 minus 12 minus 11 still less than 0. F of 2, 2 square 4 minus 12, 4 minus 12 is equal to minus 8 less than 0. F of 3, 3 square minus 12, 3 square is 9, 9 minus 12 minus 3 still less than 0. F of 4, 4 square is 16 minus 12, 16 minus 12 is equal to 4. Okay, that is greater than 0. Right now, f of 3 less than 0, f of 4 greater than 0. Compared to modulus of f of 4, modulus of f of 3 is nearer to 0. Hence, you are choosing x naught is equal to 3. That is the alternate way. Anyhow, you are choosing x naught is equal to 3. And successive approximations x1, x2, x3 are extracted from equation 1. Putting n is equal to 0, 1, 2, 3, etc. Now, if I substitute n is equal to 0, that is x1 we are getting. x1 is equal to half into x0 minus x0 plus n. n is 12 divided by x0. We have chosen x0 is equal to 3. Substitute and simplify. It comes out as 3.5. Now, second approximation to the root x2 is equal to, it is just obtained just by replacing x0 by x1. x2 is equal to 1 by 2 into 2, x1 plus 12 divided by x1. Now your x1 is stored in answer key 1 by 2 into 2. Okay, x1 is 3.5 plus 12 divided by 3.5. Okay, wherever you require the x1, you can press answer key or else directly you can compute. Correct to 9 decimal places, it is the answer 3.464285. Correct to 4 decimal places, it is 3.4643. They are not identical, x1 and x2 are. So find one more iteration. Third approximation to the root, x3 is equal to half into x2 plus 12 divided by x2. Substitute x2 value and simplify it. It comes out as corrected to 4 decimal places, 3.4641. They are also not identical, corrected to 4 decimal places. x2 and x3 are not equal, corrected to 4 decimal places. So compute one more iteration. x4 is equal to half into x3 plus 12 by x3. Okay, substitute x3 value and simplify it. It comes out as 3.4641. Look at this. x3 and x4 are identical, corrected to 4 decimal places. Hence, square root of 12 is equal to 3.4641. That is the required answer. I hope you understand this. Suppose if they ask you compute an iterative formula to find cube root of n, means you are taking x is equal to cube root of n. If you cube on both sides, x cube is equal to n you are getting, or x cube minus n is equal to 0. In this way you are proceeding. Fourth root of n means you are taking x is equal to fourth root of n. In general, kth root of n means you are taking x is equal to kth root of n. Okay, if you take kth power on both sides, x for k is equal to n, or f of x is equal to x for k minus n. In that way you can compute the iterative formula for the required roots of n it is. In the next video, if you want some more problems, we'll discuss. Okay, till that, take care. Bye.